Very good morning, dear students. Today we'll discuss about psychrometer. The term psychrometer is used to measure the temperature of air by the psychrometer. It is just like a thermometer. Suppose the function of thermometer to record the temperature of the object. For example, during the fever time, human body temperature also need to record, need to measure. In that case, what happens? Suppose we have to hold the thermometer, suppose thermometer bulb few minutes, then the thermometer bulb will sense the temperature of human body, and that temperature we can know the human body temperature. Similarly, we have to measure the temperature of air. Two types of temperature. One is a dry bulb temperature, and second one is a wet bulb temperature. And for measuring the temperature of air, we are using sling psychrometer. So this is the figure, sling psychrometer. And two thermometer is arranged in a casing. Suppose the first one, this one is wet bulb thermometer written here. This one is wet bulb thermometer. And this is the sensing bulb which is covered with wet cloth. And the temperature of air recorded is the graduation given in the wet bulb thermometer. And by the side, another thermometer is arranged, and this one is a dry bulb thermometer. This is a dry bulb thermometer. And extreme right, one handle is attached, and this handle is used to operate both the thermometer. When it swivel, as per the arrow given here, suppose from the beginning, suppose we have to measure the wet bulb temperature of air, and as shown in figure, the wet bulb thermometer, it move forward, and the sensing ball also come out from the frame, and this sensing bulb, which is covered with wet cloth, get contact with the air to measure the temperature of air, and that temperature is known as wet bulb temperature. Then suppose we want to measure dry bulb temperature. So again, we have to operate this handle. This handle is used to again swivel in the dry bulb thermometer line, so that in that time, what happens? The wet bulb thermometer will move back, and dry wall thermometer will move forward. So then what happens? This bulb of dry wall thermometer will move forward and will get exposed to the atmospheric air. And the bulb will sense the temperature of air, which is recorded by the thermometer. And that temperature is known as dry wall temperature. So this sling psychrometer operation is very simple and normally used in a different laboratory, different air conditioning field to measure dry bulb temperature and wet bulb temperature of air. So as per our discussion, the both thermometer, dry bulb thermometer and wet bulb thermometer attached side by side and arranged in a protective case, and this will be operated by a handle so that the handle can swivel and rotate easily to operate both the thermometer. So next part is our psychrometry chart to know the different properties of air. Different properties means the dry bulb temperature, wet bulb temperature, specific humidity, specific volume, relative humidity are the different properties of air. So this psychrometry chart will indicate the properties of air in the graphical way. This is the graphical representation of the properties of air. At the bottom side, this is dry bulb temperature in degree centigrade. Suppose 0, 10 degree, 20 degree centigrade, 30 degree, 40 degree, it is just increasing the dry bulb temperature of air. Similarly, in the right sides, the vertical line is drawn, it is humidity ratio or moisture present in the air, 0, then 5, 10 gram per kg of dry air, 15 gram per kg of dry air, 20 gram per kg of dry air, 25 gram per kg of dry air. Similarly, it gone increasing from the base to top, the specific humidity line. Then relative humidity. This line is curved line is a relative humidity. The relative humidity always expressed in percentage. Suppose 10%, 20%, 30%, 40%. This is the relative humidity. Suppose again this line also relative humidity. Each line represents a particular percentage of relative humidity. For example, this line is 20% relative humidity. That means here also relative humidity 20%, here also relative humidity 20%, extremity top the relative humidity also 20%. That means total relative humidity line is 20%. And this is a specific volume line. This one is specific volume line. Meter cube per kg of dry air. the unit of specific volume, that is meter cube per kg of dry air. That means suppose a value 0.8 meter cube per kg of dry air. That means for 1 kg air, it need a 0.8 meter cube space, volumetric space. Similarly also, this is complete line, it represent 0.8 for example. It is not written here, but in our practical psychrometry chart, all these things written clearly. And here another specific volume line. Here, this one is a specific enthalpy line. The green line is a specific enthalpy line. It is written here 20, 30, 40. That means 40 kilojoule per kg of dry air, 50 kilojoule per kg of dry air. That is enthalpy scale. For example, it is not given as per the particular value. It is just the graphical representation for understanding. In the practical, the psychrometry chart, it is written the specific enthalpy, that is kilojoule per kg of dry air. That means if a particular point, suppose here we got the point where the air exists in a different parameter here, then at that point, suppose the specific enthalpy will be the 70 kilojoule per kg. And this slope line, green slope line, it will represent the specific enthalpy. From here also 70, here 70, entire line. Similarly, this is 80, and in between 70 and 80, suppose one line comes in between 70 and 80. Approximately, we have to measure the length and calculate what extent it is advanced, so that in the same ratio we have to advance the enthalpy. Suppose 70, 2, 3, 4 as per the graphical advancement of the position of the properties of air. And this is specific enthalpy. So this is about the psychrometry chart. And next is different process of psychrometry. What are the different process? One is sensible heating, second one is sensible cooling, third is humidification, and fourth is dehumidification. Fifth is heating and humidification. Sixth is cooling and humidification. Seventh, cooling and dehumidification. And eighth is heating and humidifications. What happens? Suppose we want to increase the drivable temperature of air. This line is a drivable temperature. Suppose this vertical line, it will represent a particular drivable temperature. Suppose here, this is the center of the whole process. Initially, suppose the different parameter of air, suppose represent this point. Then we use a heater to increase the temperature, drivable temperature of air, so that after heating, it will reach at that point here. This is the arrow point. Suppose after heating, the properties of air will reach up to this point. and this is a constant humidity ratio line. The humidity ratio, this right side vertically it is given, the humidity ratio. At constant humidity, we are increasing the dry bulb temperature. That process is known as sensible heating. Humidity ratio is same. No moisture is added in the air. But increasing dry bulb temperature, then it is sensible heating. In the same way, instead of using heating coil, if we use cooling coil, then what happens? The dry bulb temperature get reduced. Suppose it will the parameter of air. Suppose this is the initial point and this aroid is the after cooling of air. It will reach up to this point. And this cooling process represent a sensible cooling at constant humidity ratio. The humidity ratio remains same, but decreasing the dry bulb temperature. Decreasing means it is sensible cooling. By the cooling coil, we can reduce the temperature of air, dry bulb temperature of air, and the process is known as sensible cooling. So another process is humidification. Suppose in air, we want to increase the moisture present in the air. By spraying or humidifier, we can add the moisture in the air. At same dry bulb temperature, this is suppose the initial point and this is the final point. At same dry bulb temperature remains same, but we are adding the moisture. Here the humidity ratio, suppose W1, and at the after humidifying the air, having the humidity ratio is W2, and definitely W2 is greater than W1. So this process is known as humidification or humidifying. In humidification process, the moisture present in the air goes increasing. And another process is known as dehumidification. Dehumidification, at constant dry bulb temperature, the humidity ratio go on decreasing. That means we have to use one dehumidifier to reduce the moisture present in the air. And this line represent the dehumidification process. And rest for process is the combination of two. This northeast direction, suppose the properties of air moves in a northeast direction, this point to this point, that is heating and humidification, increasing the dry bulb temperature and also increasing the humidity, heating and humidifying. The process is known as heating and humidifying. Increase the initial stage dry bulb temperature is less than the final stage. Also, the humidity ratio is increasing from the initial stage to final stage. So it is also humidifying. So heating and humidifying the air. And in a northwest direction, it is cooling and humidifying. The temperature is reduced, dry bulb temperature is reduced. That means it is cooling. And the humidity ratio increasing. Particularly, the cooling and humidifying, that means a dehumidi a humidifier will use for humidifying process, and one cooling coil is used reduce the dry bulb temperature of air, and it is represented from the origin to northwest direction. And one line represented the southwest direction, that is cooling and dehumidifying. The temperature, dry bulb temperature will get reduced, and the humidification, specific humidity also get reduced. That means dehumidifying. The process is cooling and dehumidifications. That's dry bulb temperature get reduced, and the humidity, specific humidity or humidity ratio also get reduced. And where the cooling coil is used and dehumidifier also used, both the apparatus used. And the last process is in southwest direction. In southeast direction, that is heating and humidifying. The dry bulb temperature increases and humidity decreases, heating and dehumidifying. In southeast direction, the slope line indicates the heating and dehumidification. In this process, one heating coil is used to increase the dry bulb temperature, and one dehumidifier is used. From the initial point, the humidity ratio is more than the final point, and so that the moisture content in the air get reduced by the use of dehumidifier. That means the dehumidifier receive moisture from the air, and heating coil is used to increase the dry bulb temperature. And this is the 8 different processes of psychrometry: sensible heating, sensible cooling, humidification, dehumidification, heating and humidification, heating and dehumidification, cooling and dehumidification, cooling with adiabatic humidifications. So individually, if we will discuss the cooling and dehumidification, for example, this is the psychrometry chart, and this is one initially the air supplied to us. Suppose this point, the properties of air represent in this point, and after processing, we reach the properties of air up to the point 2. The arrow given. This is the process path process followed, and this is the dry bulb temperature 1 dB1, and after processing this is drivable temperature to dB2, and the wet bulb temperature, suppose here WB1 and wet bulb temperature here is WB2, and this is dew point temperature, and dew point temperature is that temperature of air when the moisture present in the air start condensing, and this one is represented from the right side humidity, specific humidity line, that is W1, and 2 directly it will, if we will draw straight line here, this is W2, and W1 is more than W2, and this is the temperature reduce, drivable temperature reduce, dB1 is more than drivable temperature 2 dB2, so temperature reduce and humidity also reduce, and 1 to 2 process is known as cooling and dehumidification. So next is cooling and humidification. Suppose instead of doing a dehumidification, if we want to humidifying the process, cooling and humidifications, then the process will follow like the initial stage 1, and this is the point 2, and this is the drivable temperature dB1 and the drivable temperature dB2. Drivable temperature reduce, but the specific humidity increases, that is W1 and W2. W2 is more than W1, initial stage humidity is more than the final stage. So this process is known as cooling and humidifications.